Assalamu alaikum. Hi everyone. This is Ayman Muhammad, and today I'm gonna show you how I did the propeller for the quadcopter design. Well, as we can see, first of all, we started with the center of the propeller. Excuse me. As we can see, the propeller center consists of uh, basically an eclipse shape with a height of 5 mm and the diameter of the eclipse of 10 mm as well. So for the propeller, we've designed a pitched propeller with a various pitch angle along the propeller's length, or the span of the propeller. So this is what we did first for the propeller span. We've created three planes, three separate planes for our profiles, and where we wanna have the profiles laying from the main ZX axis. So we can control these by making an offset. For example, at 10 mm, we can see that the first profile of the airfoil has come closer to the main center. By doing this, we can control the overall layout of the plate and also the pitching angle along the span. So we will just restore them in position. So for our design, we made the first profile at 200 to 20 mm from the center, and the second plane 40 mm from the center, and finally the third plane at 70 mm. So we will have a total plate span of 70 millimeter. Okay, so now we make the first profile. This is the first sketch. We already explained. It's a very simple. We use the eclipse tool. Okay, yeah, it is this one. We can sketch the eclipse like so. After that, we will move on to the second sketch, which is the first profile of the airfoil. This is the main airfoil, and these are the corresponding dimensions for the first airfoil. And then for the second airfoil, we do not have to draw it. Actually, on how to draw on this plane, we just select the plane and then hit sketch, similar to the main 3XYZ planes. So for the second, not this one, from the third profile, for the third profile, we do not have to draw the thing, so we can just hit the projection and, for example, hit this one. So we will see that it already created a projection from sketch 2 in our new plane. So we don't have to redo the thing again. So after we projected already the first profile, we can do is to scale. So we can scale this one from here, and then we hit the scale value, for example, 0.5. So we can see that this one is already created. So we will delete the first one and also delete this one because we already finalized about this sketch, which is scaled at 0.75 at an angle, and then we manually change the angle, the pitch angle, to be at 7.5 angle from the longitudinal axis. Okay, and similarly for the final airfoil, we just project it into this plane. It will be already constrained, and then we just have to manually scale it down to the scale value that we want, and then constrain the angle from the longitudinal axis. That's how we create the section profiles for our propeller. Okay, now we want to connect all these parts as smooth as possible without creating any error. So that's why we have to move to mechanical design, wireframe, and surface design. This tool allows you to have more control over surfaces and how you can create surfaces easily without avoiding with avoidance to the errors that might create when doing so in the 3D modeling part. Okay, so the first step is to we will disassemble our blades that we will create into upper section and lower section. So we will first create the upper surface of the plate and then the lower surface of the plate, and then hence we will have an finalized plate. So for doing so, we will head the disassemble, not the split. Okay, not the split, the disassemble. This command, the disassemble, we will hit on it, and we can see that this element is already one. But if we hit, for example, we have sketch one, disassemble, we will see that the input is one element, which is the clips, but the output, it will be two cells. So that's what we did here, and we had the upper curve and then the lower curve as a result of the disintegrating of the eclipse. For the airfoil, though, we did not use the disassemble. We use another tool, which is extract. Where is it? Extract. Okay, the extract tool. Healing, uniform, join. Okay. Okay, resuming back, this is the extract tool. We can select the element that we want to extract. So if we select this edge, it will extract this edge, as you can see here, extract 5. And then here, OK. So this way you already extracted element extract 5, 6, 7, and 8 for this one, this edge, and also this edge. And then we use the join command, not the disassemble, here the join command. And you can see we join the upper surface of the plate of the airfoil, as we can see in join 7. And also join 8, we join the lower part of the airfoil. 2. So overall we have from the, let's repeat again, from the Eclipse we extracted the upper part and the lower part, and for the first airfoil we have extracted all elements and then joined the first part, the upper part, and then the lower part. So I think you can see what I'm planning to do now is to connect the first curve, the upper curve from the Eclipse, with the first join, which is the upper part of the airfoil. And doing so to the other airfoil, just repeat again, extract the first element, second element, so you can see, extract the first element, second element, third one, and the fourth one, then join the two upper surface and then the two lower surface. So we will have total of upper and lower surfaces. Finally, the same process for the final airfoil, extract first, extract second, third and fourth, then join the upper and lower surfaces, and then we will be ready to do our multi-section surface. So for the multi-section surface, as we can see here, the input is where are the points that you want to extend the surface to. So you have, let's do this again to show you guys. This is the multi-surface. So what I want to do is to connect my upper curve here. These are where you select the elements that you want to connect first with. And then the second element is the upper part from the airfoil. And then the upper part for not section. This one you can hit remove. Okay. Okay, we want to add. So we want the upper surface of section 3. Where is it? Okay, this one. Yeah. And then the upper surface of the last airfoil. Since I already selected all the upper surfaces, so I can just hit review. And this surface has small edge. Okay, we know that our last airfoil is very small, so we'll have smaller edge. So that's how you execute the multi-surface option in CATIA. And make sure that you have all arrows are pointing in the same direction. This indicates the closing points for where the software can start and end the surface. For example, if the arrow is one down there, this will create an error. So yeah, this mistake has been often done. So make sure that all arrows are pointing in the same direction, then hit review, then your upper surface is created. So then you have to hit cancel because we already have our upper surface. And then we will do the same process for multi-surface for the lower plate, for the lower section. As you can see, we will connect this one. We connected this one, the lower surface, this lower surface, and also this one. Review. Oh, I'm hiding it. So just let's show. That is the full surface of the plate. So let's just hide all the sketches as well as the planes. Yeah, so this is our final planes, the final plate. after we connected the upper and lower parts. So this is isometric view. This is top view or plate. This is the section where it will be connected, and this is a front view. Okay, let's say that we are not satisfied with the length of the plate and then we want to change it. As we mentioned before, we just go to the planes. For example, the third plane, which is the end of the propeller, which is a 70 mm from the hub. We want to extend it 10 millimeter more. We can just hit here. We can make it 80 and then review. Okay, this error. It's not an error. This is just a warning that our edge is just very small, but eventually. Okay, housing element cannot be cut. Okay, yep. So yeah, this is now we have our blade with an offset of 80 mm, but it's quite long, so we just don't want to do that. So after we are satisfied with our let's say with our measurements and all the dimensions of our planes, we can just move on to the body parts, and let's go to the part design. And what you want to do in the part design is that you just want to create a 3D body, 3D solid model out of your surface. And to do that, you have to, okay, let's hide the melt. No, before that, let's show you how we did this. Okay, the plate, this is, I named it the plate, but this tool is the thickness. So to do so, you have to do insert. Okay, surface-based feature, closed surface. And then when you do the closed surface, just select your 2D plate surface and then create OK. This will give you a 3D solid. Let's hide them. And yep, but we colored it in black. So as you can see, this is a 3D model. After we closed it, we used the closing tool, which is this one here, close surface. It created a 3D solid surface out of our 2D surface. And before that, you can just join the plate surface. I named it here, for example. I used the join that we used before to join the upper and lower surface, and then named it plate surface. And then here I've created this closed surface and I named it the plate, which as you can see in the part body section, which is a 3D. And above that, this one is just a geometrical set for our plane references. I named it ref as a reference for our planes. And here, the first geometrical set is for our 2D surfaces and the disassembles and extractions that we made for the airfoil elements. Okay, so after we had our 3D plate, as you guys know, we will do our circular pattern. So we already have, we already decided that we want to use 4 instance. So we selected a complete crown. So you just hit the instance and then the rotating axis. I want to this plate. I want this plate to be in 4 instances, rotating about the z-axis, and then preview. For example, let's say if we want 3, we hit preview, and it already we will select the angular spacing for you. You will do the calculation. Okay, so let's made it for as we chosen the preview. Okay, so after that, we have to design an attachment for the propeller to the motor housing, and by doing so, we just have to create a sketch on the XY plane at a diameter of 10 mm. And as you guys know, for this design, assembly design, all the holes will be selected to 5 mm. So this will give us a room for the hole, which is going to be inside this with from the same from the same from the same point. So after that, we just pad the circle that we've just made. We have mirror extended, so it will be from the top and then the bottom. For example, let's say if we did not want that, so it will be just from the, it will extend only upward, and we will see that downward. This is not the perfect place where we can uh, connect to the motor housing. So we want some rectangular shaft, so we can just dig a hole through it and then connect the motor housing through it. So therefore, that's how we mirror this one. Hit preview. So now we have a solid cylinder, so we can just hold it, make it a hollow cylinder where we can attach the motor arm, the motor shaft to rotate the propeller. And finally, we made the hole inside this cylinder, which is the center of the propeller. As you guys know, this is a very easy command. We just hit the diameter of our hole, and the depth, we don't want it to be up to next or up to last. We want to define the defined measurement for the depth, so the shaft of the motor will be inserted here. Okay, and this is the position of the hole. We made the center of the hole at the center of the plate. Okay, so we will exit that, and then finally we have the hole. As you guys can see here, where the motor housing shaft will be inserted. Okay, so this is our final plate. Thank you very much guys for watching, and stay tuned for the rest of the parts.